Hello and welcome to yet another South Korean College Scholastic Ability Test video. Today we will solve the following problem. In the figure, rectangles AODB and OFGD are congruent, and rectangles BDEC and DGHE are also congruent, which are pretty self-explanatory by the figure. A linear transformation moves point B to point E, so point B to point E, and point D to point A, so point D to point A. By this linear transformation, point A is moved to one of these 5 points, and we have to find which one. Alright, first of all, we need coordinates. So let us assign coordinates to these points. We have point A here on the y-axis, so let this point be 0, A. Then, by the symmetry, the coordinates of point F is 0, minus A. Next, let us take a look at points on the x-axis, which are D and E. So we let D, 0 be the coordinates of point D, and E, 0 be the coordinates of point E. Then, point B is D, A, point C is E, A, point G is D, minus A, and point H is E, minus A. Next, let us remind one of the most important aspects of linear transformations. A linear transformation on a two-dimensional plane can be represented by a 2x2 matrix. So let M be the 2x2 matrix of the linear transformation given in the problem. Then we can set up equations from the given conditions. First, it is given that point B is moved to point E, so we have matrix M times the column vector dA equals the column vector E0. Next, we have the condition that point D is moved to point A. So matrix M times the column vector D0 gives the column vector 0A. So we have these two conditions. And the cool thing about matrix is, we can combine these column vectors and write M times 2x2 matrix dA D0 equals 2x2 matrix E0 0A. So we have this equation. From here, matrix M can be obtained by E0 0A times the inverse of matrix DA0. So first we have to find this inverse matrix. And the inverse of a 2x2 matrix can be found quite easily by this simple formula. So the inverse of this matrix is 1 over D times 0 minus D times A, so minus AD. Then the diagonals become 0 and D, and this entry is minus D, and this entry is minus A. Here, we can take this real number minus 1 over AD to the front and write minus 1 over AD times E0 0A times 0 minus D minus AD. Here, let us do the matrix multiplication first. If you do the calculation, you will obtain 0 minus DE minus A squared and AD. So if we multiply minus 1 over AD, we have matrix M equals 0 E over A over D minus 1. So this is the matrix M of the linear transformation given in the problem. Now, using this matrix M, let us move point A, which can be done by M times column vector 0A. So this matrix 0 E over A over D minus 1 times column vector 0A, which gives E and minus A. So point A is moved to point E, minus A, which is this point H. Therefore, the answer is choice 5. And that was all for today's video. Thank you for watching, and I will see you in another video.